you end with the issue about the sun and the sun behind the clouds and the sun behind the horizon and all that kind of stuff. So I make a little simulation trying to emulate this, because if you are looking very, very, if you focus here, you can see clearly that that line down is a mirror of the image is above. This is you can see clearly that is a mirror image. It's not the real image. So I am a C4D user, and trying to emulate this in computer, I start to have to try to put this optics phenomena together, and I create this file, this a scenario that I create a simulate atmosphere in C4D that it's like a glass, but with different index of refraction based on a gradient ramp, which is like a noise map to try to emulate that distortions in the air, little distortion, because you're not going to have a lot of distortion. So then what I do was I put this is like the sunlight, right? This is the sun, and this line here, this white line here, is the cloud, the cloud plane. So the sun is always on top of the cloud plane, and I move the sun in a linear fashion. I don't make any circle, nothing about that, because the distance is very short. But I move it always on top of the line of the cloud, like you see here. If I show you on perspective, this is, I hope you understand me what I'm presenting.
Absolutely.
Okay,
You're
perfect. I'm a little nervous. Sorry.
No worries. You're doing great, Hero.
Okay. So this is cloud simulation. These tiny points are simulation cloud with volumetrics parameter. It's not like a solid object. The software allow to calculate, the light pass through volumetrics object. So the cloud is made with that kind of parameters. And I started the animation. I'm going to show you the end result, because the render is taking a lot. But what you see here is like this. The sun is always above the clouds. We are on the seashore, and I make the suns go away, so you can see the light also travel with the sun, and with the suns touch the horizon line, of course it's going to disappear. But if we make a zoom, you can clearly see the sun again, but cut in half, right? But like you see in the simulation, the sun's never going down. The sun, it's never going down the cloud. So why it's cutting off also in the computer software? That is because we simulate an atmosphere. So anytime you simulate an atmosphere, when you reach a distant point, the light is start to bend. So if you make a zoom, you can see that even the cloud is this straight line, and the clouds above here start to going down also. That is something we all see in this kind of sunset. Let me just...
Right, so this is also the same effect that, we see these pictures of people filming the sun, and they see the clouds that appear to be going behind the sun, but obviously they're not. But this is the same type of effect, isn't it?
Yes, it's exactly the same. That is for overexposure of the light that you see. That it's impossible that the clouds go behind the sun. It's impossible. But what is possible is the overexposure of the light of the sun mixed with the light of the cloud, but never go behind. That's never. And all of these phenomena are just atmospheric distortion, and it's all the time, everywhere on the plane. There is not an isolated phenomenon. It's all the time. That is why I show at the beginning the web page where you can check, because maybe you are working on the sea or things like that, so you need to have that atmospheric, statistic to work. So all the time what you see is this kind of phenomenon. I mean, other thing totally different, it's the sun dogs. That is a phenomenon that maybe you can only see if the light condition and the temperature and the location and the perspective of the viewer need to, be a little special. This is what is called I think in English is anisotrophic light. This is a phenomenon explained by Gauss and Faraday. I also have a simulation about this, but this is show us that we live like in a personal dome, a personal bubble all the time. It's dependent of the viewer where he sit this phenomena. Maybe it's like a rainbow. You can triangulate a rainbow. Maybe a person in one location see a rainbow different than the other. So this is what is happening with the light. We live like in a a personal bubble.
Right. So this is kind of going right along the lines of, I don't know if you saw last week's show or not, Iru, but
yeah,
how we were talking about, the sunlight and the apparent sun position is fairly unique for everybody, every observer, right?
Yeah.
And that's
right.
Kind of the same exact type of thing. Of course, their theory is that this has to do with the magnetic flux lines distributing this image, but it's actually a combination of several things, I believe, but the magnetic flux lines are definitely part of it, and we've been talking about that for a long time.
For example, in this scenario, we have this, like bubble, personal bubble. This is like a piece of glass, like a dome of glass, and we have only a single light. Okay, this is the light, and this is the render in real time. It's a little bit noisy because it's real time processing, but this is Arnold render. It's a software. It's a standard in Hollywood. It's one of the most render software that are available for movies, films, and a lot of things. So you can see here this software render computes anisotrophic lights, and for example, this is the specular light on a personal dome. Like you can see, if I put the light on top, of course, if a person was inside this dome, is gonna see, the sun like every day you see it. And if I move the light linearly, you can see how the reflection of the light is bending, and that is what happens when the light comes in the horizon. In fact, you can detect this because if I make a zoom, you can see how the bottom of the sphere light is compressed. And when you compare these kind of things, for example, I think this is one of those, you can see here, this is a sunrise, you can see how the light is also compressed on the bottom part. You can see here is totally clear, this part is mirrored down, and that is because we see all the time this personal bubble. So we live in this kind of personal bubble. So if the condition of the weather, make this phenomenon of an anisotrophic light, what you're gonna see is a single light like this, but dispersing. You can start, I'm going to make a zoom out. You can see how this, let me just start to, you can see how the light is straight, is bending, and then when you reach a certain parameter, you can see how one light, start to make like a round light, even double, and everybody, it's interesting, yeah. Everyone maybe see that kind of double rainbow. In fact, if I started to make a dispersion aberration, you can start to see that rainbow, because the rainbow is just simply in dispersion of the light in the air. So for me, it's very clear that we live in this kind of personal bubble. So all these phenomena of the main issue here is that the people need to start to think that the light bends. So when you incorporate that on your mind, you are going to start to, you know, to understand a lot of optical phenomena. Sorry, why we see the moon flat and also maybe the sun flat too, because here is another simulation. I can show you. Let me present the environment. I create this, you know, the same thing, the type of dome with this dispersion of the light and things like that, and I put the sun on top. It's irrelevant, the distance, because we are seeing here is an optical thing, not the measurement. So I put the sunlight on top, and I move it again, you know, linearly, very, very far away, very quickly. So the thing is here, for example, if I go out like, you know, a balloon or maybe a rocket, and I see the sun, always I'm going to see, you know, like perceive like a sphere. But if I enter inside this kind of environment, when I render, I'm gonna see flat. The same sphere, of course, is, you know, turned into a flat surface. So that is why the moon maybe could be a, you know, a hemisphere, maybe could be a sphere, but all the time, if you're gonna look it from the ground to the sky, all the object on the sky is going to be projected in the, you know, the Karman line. So you're going to see just a projection in the air. It's impossible to determine if it's spherical or not, because it's a, you know, it's like this glass effects that we live on. In fact, here is very clear. If I put the camera on the ground, you can see, for example, the sun, it's there, but when I compute, all the time it's gonna, you know, appear down. Physically it's up there, but if you, a lot of people that try to debunk this phenomena on computers, they don't recreate the atmosphere, they just make it geometrical correct, but the computer doesn't have an atmosphere effect. So you need to emulate that on top, because if not, is geometrical speaking, of course, if I, you know, make the sun go away, never is going to touch the horizon, because geometrical in the real life that never happened also. So you need to add this kind of simulation on top, because if not, you are not going to replicate the reality.